Okay, so this is Tuesday's lesson. It's going to be a tough one, okay? So just bear with me. Remember that you can watch the video over and over again. I'm going to do my best to kind of connect some dots. But because this lesson is so hard, I'm just going to give you guys this and then the practice. And Wednesday's lesson, we're going to kind of slow down a little bit and hit it when I come back, okay? So don't panic if you're confused by this. Watch as many times as you need to. And just do the best that you can. Luckily that once this is recorded, it's always there, so you can always go back to it, okay? But I think we're gonna connect some dots today that'll hopefully help out a little bit. All right, so as a warm-up, what do you notice, what do you wonder? Okay, so if you look at these, we have x minus 3, x plus 5. This is what we would call factored form. They're saying that it's equal to x squared plus 2x minus 15, which is standard form, and the way they get that is by multiplying in the box. Right, that's nothing new for us. So a couple things you might notice is that these are multiplying, they're boxing, we're going from standard form to factored form, bunch of different things, okay? So standard form to factored form. By multiplying, okay? So inside the box is when you multiply, x squared comes from x times x. 5x comes from 5 times x, and so that's how you multiply. We set up the box to kind of keep it organized and tell you what you're multiplying on the inside. Same thing with this one. Now you see another factored form polynomial, which is ultimately going to end up being rewritten as a standard form polynomial because of our multiplication. So we take this trinomial here, or this 3-term polynomial, and put it up top. We got a 2 by 3 box, and then we're just multiplying as we go. Okay, so we've seen this before. And then when you come down to this one, what you notice is that we have a partially factored form. This one up top, this should be factored form to standard, not the other way around. Okay, so we're going from factored form to standard. This is standard, this is factored, okay? So we have a partially factored form right here, and we're trying to figure out, or we already figured out what the standard form of that is, but what's missing is our multiplication partner here. That's why this looks incomplete, okay? So if you look at it, we have the x minus 2 on the box, but we don't have the other term to put up top. All we have is our answer. So what we're gonna learn to do today is fill in this box by working backwards and find out what our multiplication partner is, okay? So if you come up here, these factors, x minus 3, x plus 5, that's what goes up top. And then this was inside the box. This one, this times this on the outside. This was the inside. This one is the inside, but it's not filled out. Why? Because we only have one of the outside terms. So we can use what's supposed to be on the inside to work backwards and find what goes on top. That's what polynomial division is. And that's what we're going to do today. All right, so for 12.2, this is where it gets a little tricky, okay? Priya wants to sketch a graph of the polynomial defined as this. So we're going to really want to pay attention to this. I'm going to write off to the side. X cubed plus 5x squared plus 2x minus 8. We're going to want to keep a look at this the entire time that we're dividing this, or factor with a diagram, or whatever you want to call it, okay? She knows f of 1 equals 0, so she suspects that x minus 1 could be a factor. And so then what that means is she thinks that we can multiply this to something else to get this as a solution. Our goal, figure out what this is to finish the diagram, okay? So to figure out what we're doing with the diagram, you take the first term of your polynomial and that goes in the first box, okay? And then we just work backwards. So we know that this x cubed was a result of this times this, right? Like in a normal box, you multiply this by this, and that's what goes here. So we can identify what this term is by figuring out what do we multiply x by to get x cubed, okay? So if I put x squared right here, that makes sense because x squared times x is x cubed. So that works. So then I take x squared, multiply it by -1, and I end up getting a negative x squared there. So that's the first column, okay? So now we're looking at x squared, right? So we want x squared, according to our original polynomial, we want x squared to be 5x squared. So then the question becomes, how do I get from a negative x squared to a positive 5x squared? How do I get from a negative 1 to a positive 5? Well, to do that, I would have to add 6x squared. If I combine these two, a 6x squared and a negative x squared gives me a positive 5x squared, which is our original polynomial, okay? So that's why this goes here. Now I have to work backwards. X times what gives me 6x squared? Well, that solution is just going to be 6x. Okay, so if you're still confused, look at it like this. X squared times x was x cubed. 6x times x is 6x squared. Okay, then we'll take the 6x, move it down here. Now it's a negative 6x because 6x times negative 1 is negative 6x. And we're going to look at 2x now. How do I get from negative 6x to a positive 2x? Okay, that's going to be adding 8. I need to add 8x. 8x minus 6x is a positive 2x. So we're using the standard form polynomial to work backwards, okay? So now that we have this box figured out, it's 8x. How do I get from x to 8x? Well, I multiplied by 8. So that's what goes up top. 8 times x is 8x. 8 times negative 1 is negative 8. And this box right here is the kicker. This box always needs to match the constant term in order for this to be true, okay? So go ahead and take a deep breath. This seems a lot harder than it actually is, okay? Don't overthink it. Basically what we're doing is they give you your answer as the standard form polynomial, right? This is your answer. They give you part of the box. You're trying to identify the other part of the box given the answer, okay? So we're working backwards. We have this. We know that we have to multiply this by everything here because that's what we do in a box. So they give you key pieces from the given polynomial and you can work backwards. So that's how you would finish that diagram. All right, if you're confused, there's going to be more examples, okay? So don't completely panic yet. So number 2 says, write f of x as the product of x minus 1 and another factor. So what that means is we're just going to write this and this in parentheses, okay? We have x minus 1, because that's right here, times x squared plus 6x plus 8. So we're just taking what our two outside terms were and we're multiplying them. For number 3, they say write f of x as the product of 3 linear factors. So maybe you are familiar with knowing that this right here needs to be factored, okay? Maybe you're good at factoring, maybe you're not. We're gonna work on it. For today, I'm just gonna show you how to do this one and then we're gonna kind of take it easy, all right? So don't panic. But when they say write a product of 3 linear factors, that means we have to factor this big one. To factor the big one, you look at the last term. So my last term is 8. I'm going to write that off to the side here. I'm going to write down all the numbers that multiply to 8. 8 times 1, 4 times 2. That's it. Okay. So these are all the numbers that multiply to 8. So then what I do is I got to figure out what numbers multiply to 8 that combine to be my middle term, which in this case is a positive 6. Okay. So if I combine 8 and 1, either through addition or subtraction, it would be 8 plus 1 would be 9. 8 minus 1 is 7. Doesn't matter. Neither one of those is 6, so I can't use this. Okay? For this one, 4 plus 2 gives me 6. So because 4 plus 2 gives me 6, I'm going to rewrite this as x plus 4, x plus 2. And then the x minus 1 just comes down. All right? So 4 times 2 gave me 8, while also 4 plus 2 gives me 6. Okay? If that completely confuses you, don't panic. We're going to get some more practice when I get back from Nashville. All right? But now you have factored form. You have 3 factors with a degree of 3. So when they say make a sketch, now we're going to use all of our notes from the previous week. I'm just going to graph each one of these. So I have an x-intercept at positive 1, negative 4, negative 2. It has a degree of 3, which means our end behavior is opposite, and this is a positive graph. Okay? So degree of 3, which means x-intercepts, 3 x-intercepts, opposite endpoints, so it's going to look something either like this or like this, depending on if it's positive or negative. In this case, it's positive, which means the right side goes up, and the left side goes down. So that's kind of where my endpoints are going to go, and they have to go through each one of these points. Notice that each x-intercept, none of these are repeated. So at the graph, I go straight through every single time. Remember multiplicity, if it was to happen twice, it would bounce. If it happened 3 times, it would bend. But in this case, each one of these x-intercepts only happens 1 time, so it goes straight through. All right, so the majority of today is just going to be focusing on this and writing it like this, okay? The factoring and the graphing is our ultimate end goal for this unit, okay? We're trying to get to be able to connect all these dots as one. So the box method takes us from factored form to standard form, okay? So factored form to standard form. But this isn't complete factored form because this can be factored again. All right, so there's a lot of moving parts here. Don't get confused, don't get upset or anything like that, just stay with me. Okay. So we're gonna get some more factoring with this one. If I was you, I would watch number 1 and then pause and try number 2 on your own, okay? But if you feel not very confident, it's okay to just keep watching the videos. That's what it's here for. All right, so they gave us a factor of x minus 7 that goes over here. They gave that to us. They will not always give it to you, but in this case they did. And then they give us our normal polynomial, okay? This is important. So I'm gonna write this off to the side again, just so that we know it's important. I'm putting it off to the side bigger so that I remind myself and I don't get confused about everything else. So standard form polynomial, one of my factors, I need to use this to work backwards and figure out what this was multiplied by, okay? So you take your first term on your polynomial goes in the first box, okay? So x squared times x gives you x cubed, x squared times negative 7 gives you a negative 7x, so then you can move forward, okay? If you look from negative 7x squared, that's exactly what this is in the polynomial. So we don't add or subtract anything, that's why you see a 0. Anything times 0 is 0, so this whole column is just 0. All right, so the next thing that we need to work with is an x. Okay, so we already took care of x squared. Now we need to focus on negative 16x. How do I go from 0 to a negative 16x? By going negative 16. Okay. When we combine these, that's just negative 16x, which is what it is in the chart. So right here, this is where I get my x, right? So x times what gives me negative 16x? Be a negative 16. If you're confused, negative 16 times x is negative 16x, so I just worked backwards. And then negative 16 times negative 7 is a positive 112, which better happen because that's my constant in the polynomial. So that proves to me that this is good. So then when they say rewrite each polynomial as a product of linear factors, x minus 7 is your first one, because they give that to you. And x squared minus 16 is your second one. That's your answer. We could factor this further, but I don't want to spend a whole lot of time on that today. I want to get comfortable with the box before I start throwing a bunch of other stuff in there. Okay, so let me move on to number 2. They kind of did this one for you. All right, so here's your given factor. You're going to want to calculate for this one because it's a fraction and we all hate fractions. So this is your standard polynomial. I'm going to write it down here so that I can refer back to it. 2x cubed minus x squared minus 27x plus 36. You don't have to write it down here because it's literally right here. But I write it because this doesn't confuse me. All these numbers together kind of confuses me, so I like to separate it. Okay, so the first term, you notice 2x cubed is the first thing in this box, and then we can work backwards from there. Okay, to get to 2x cubed from x, you have to multiply by 2x squared. X times 2x squared gives you 2x cubed. So then you take 2x squared, multiply it by negative 3/2, and you get negative 3x squared. And so what they do here, to get from negative 3x squared, so you're at negative 3x squared right here, you want it to be just a negative x squared. How do you get from negative 3 to negative 1? You add 2. That's why this number is right here. Okay, so x times what gives me 2x squared? 2x. 2x times x is 2x squared. That's why that went there. 2x times negative 3/2. Put that in your calculator. So I would have 2 times negative, and then if you hit alpha y equals, this is a fraction button right here. So then you can type in 3/2. Hit enter and you get negative 3. So 2 times negative 3/2 is a negative 3x. All right, so now we're looking at the singular x's. I need this negative 3x to actually be a negative 27x. So what do? I combine it with a negative 24x. Negative 3x, negative 24x gives me negative 27. All right, so remember that when we're circling in the box, the diagonals are combining. So negative 3, negative 24 is negative 27. Then I use this to fill out the top. X times what gives me negative 24x? The answer to that would be negative 24. Negative 24 times negative 3/2 is 36. So this is 36. And if you look at that, that's the last term in our polynomial. So we did it correctly. So then to write it as a factored form, it's x minus 3/2 times 2x squared plus 2x minus 24. Okay. So at this point, you've seen me do 2 examples. You're probably super overwhelmed. I want you to take a deep breath, maybe go to the bathroom, get some water, come back and try the rest of them on your own. And pause this, and then when you pick it back up, when you hit play again, it'll be me doing the answers to the video. Okay, this is me assuming that you paused, took a little break, and now you're ready to check your answers. So here's our polynomial. I always like to write off to the side, nice and big, so I can refer to it easy. Once again, you do not have to do it. So here's our polynomial. This is our given factor that they put here. Now we're going to work backwards, okay? So this one's a little different because they didn't give you anything to start off with. But if you've been paying attention, you know that the first term in your standard polynomial is the first term in this box. And then you work backwards from there. So x times what gives me x cubed? X squared. And then I bring that down here. 3 times x squared is 3x squared. So now I'm worried about x squareds. How do I get from a positive 3x squared to a negative 3x squared? Through addition or subtraction. Well, that's going to be a negative 6x squared. If I combine these, 3x squared minus 6x squared, or 3 minus 6, I get negative 3, which is what I need it to be. Then I can work up from here. X times what gives me negative 6x squared? That would just be negative 6x. Bring it down here. It's a negative 18x. So now I'm looking at just single x's. I need it to go from negative 18 to negative 13. So I'm going to add 5x. X times what gives me 5x? That's a positive 5. 5 times 3 is 15. That's the last term in our polynomial, so we're good to go. Your answer is x plus 3 times x squared minus 6x plus 5. All right, number 4 is a tricky one. They gave you a hint, and I'm just going to explain that hint a little bit. So if you look at this, it goes x to the 4th minus x squared plus 36. So we're missing x cubed and just a single x. So when you're referring back to the original polynomial, you have to refer to those as 0. And you'll see what I mean here in a minute, okay? So I'm just going to use this. I'm not going to rewrite that because it's a little confusing. And so then, if you look, they gave you 2 parentheses here, x minus 2 and x plus 2. Doesn't matter which one you use. You can literally use both of them. What they're ultimately trying to say is that when you see 2 of these, you're probably going to have to do it twice. But I don't want you to do that today. I just want you to work on getting solid with the box in the first place. Okay. So I'll just do x plus 2. You could do x minus 2. It really doesn't matter, okay? But I'm choosing x plus 2. My initial term in the polynomial is x to the 4th, so that's going to be what goes here. And then now I can start to work backwards. X times x cubed gives me x to the 4th, and x cubed times 2 is 2x cubed. Now I'm looking at x cubed. Well, if you look, x cubed is at 0, so how do I go from 2 to 0? I subtract 2. 2x cubed minus 2x cubed is 0x cubed. That's why we put in the zeros here, because we have to account for every single x value, okay? X to negative 2x cubed is just a negative 2x squared, which means this is negative 4x squared. We need to go from negative 4x squared to negative 13x squared. That's going to be a negative 9x squared, which makes this a negative 9x, and this a negative 18x. Now we're looking at the x's. I need to go from negative 18x to 0x. How I do that? Add 18x. X times 18 gives me 18x. 18 times 2 is 36, which is the last number in my polynomial. So my answer is x minus 2, x plus 2, x cubed minus 2x squared minus 9x plus 18. Okay, so what we're ultimately going to try to get to is after you use one of these factors, you have to use the other factor to simplify this. So you would make another box. Okay, that's what we're going to get to. We're not going to do it right now. I just want to make sure that we're solid with the box, okay? So then for number 5, it's going to be the same exact thing. They give you 4, 3, 2, 1x. Okay, so we don't have to worry about any 0x's. And then they give you 3 options to choose from. It does not matter to me which one you choose. I always like to do the positive one first. I don't know why, it doesn't matter. But x and positive 3. All right, and then I'm trying to match it up with 4x to the 4th, negative 15x cubed, negative 48x squared, and so on. So here's my factor. My first term is 4x to the 4th. That goes inside the box. Then I work backwards. 4x cubed times x gives me 4x to the 4th, so that's why I went up top. 4x cubed times 3 is 12x cubed. And now that I'm on x cubed, I need to see what it needs to be. All right, so it needs to be a negative 15x cubed. So how do I get from positive 12 to negative 15? That's where the calculator comes in handy. Okay, so 12 plus 15 is 27, but it needs to be negative. So this is going to be a negative 27x cubed. When I combine these, negative 27 plus 12, I get negative 15, which is exactly what I need it to be. Then I can work up. This will be negative 27x squared, and this would be negative 27 times 3. This is a negative 81x squared. So now the numbers are getting kind of large, so make sure you're relying on the calculator. So now we're looking at x squared. I need it to go from negative 81 to a negative 84. So I'm going to go 81 minus 48. Oh, sorry, 48, not 84. So I'm going to need to add 33x squared, which makes this 33x, which makes this 99x. So now I'm looking at the x's. I need to go from 99x to a positive 109. That's just by adding 10. X times 10 gives me 10x, and that is 30, because 10 times 3 is 30. So then if you look at this one, 30, 30, I'm done. So I would have x minus 5, x minus 2, x plus 3, 4x cubed minus 27x squared plus 33x plus 10. All right, and just keep in mind that you would need to do the box again for this one. We'll get there. You didn't have to do it today, but eventually you're going to have to choose another factor and do it again to be able to factor this.